Welcome back. We are returning to solving equations, and we are going to step into the very first form of nonlinear equations, which is quadratic equations. Quadratic equation has a quadratic term, x squared, in addition to the linear term, bx plus c. Now, you must have seen in textbooks that they give you this formula. These are the solutions to the quadratic equation. Just plug in a, b, and c. I don't like that approach because that is rote memorization. So instead, we are going to look at something that you can understand and relate to. Let's start with this equation. 5x squared minus 15x plus 7 equals 0. How do we go about solving it? Now, whenever you have a problem, what you want to do is boil it down to a simpler problem. Now, here is a really simple problem that we all know how to solve. X squared equals a. What are the solutions to that? The solutions to that are simple. X equals plus square root of a and minus square root of a, provided a is greater than 0, greater than or equal to 0. So now I would like to put this equation in that form. How do we do that? So first of all, let's get rid of this coefficient in front of x squared. How do we do that? We divide all throughout by 5. So if you divide by 5, you get x squared minus 3x plus 7 over 5 equals 0. So now we still don't see how we are going to get x squared here. So let us remember that there is this beautiful identity that you must have come across. X minus a whole squared equals x squared minus 2ax plus a squared. So that is what we are going to summon in order to achieve our square. So we have these two terms involving x squared and x, and that has to somehow map to these two terms which involve x squared and x. So let's see if we can put that in a whole squared form. So we've got x squared, and then the next linear term must look like 2ax. 2 times x times a. Now what is that a going to be in order to get a minus 3x? So that a has to be 3 over 2. Then this term becomes minus 3x. And then in order to complete the square, you need an a square. So I just created this a, which is 3 over 2. So you have to add 3 over 2 whole squared in order to turn this into a perfect square. But now you're saying, wait a minute, you have kind of messed up the equation. I had a 7/5. What happened to that? Right? Very good point. So what we're going to do is we're going to take the 7/5 over to the right-hand side. We'll write it as a minus 7/5. But then I also introduced this 9 over 4 on the left-hand side. So I have to add a 9 over 4 to the right-hand side as well. So now this equation is exactly the same as what you had earlier. So what? So we have an easier problem to solve. So this thing looks like x minus 3/2 whole squared equals 9 over 4 minus 7 over 5. Let's solve this quickly. It's 45 minus 28 equals 17 over 20. So now you see, here's your easier problem. Now this is my capital X. Well, that is my square, and that equals this positive number, which means x minus 3/2 is either equal to square root of 17 over 20 or minus square root of 17 over 20. And from that, it follows that x, now we are bringing this 3/2 over to the right-hand side. X equals 3/2 plus or minus square root of 17 over 20.